All right, I am Donovan Unruh, and this is the second assignment for Comp 251. This is the calculator expression tree project. So to go over a few things at the beginning, um, I have the the variables I use, or the data values I use here. I have expression tree, and I have error, and I have the hash map. So I have my error here, which is just an empty expression tree. I use this whenever I need to basically the exit one of the methods without returning a incomplete tree. So I just have it return 0, just because that's a safe number to return. And this is the hash map, which uses integer and string. That's what I use to basically assign values for the variables. So this is the main bulk of the program, the calculator program. So the very first thing that happens is when I have the test here is I have calculator run. So I run the the values here with whatever argument has been assigned. In this case, it's 0, which would be this right here. So the very first thing I do is I grab the file and I check for a parse, which I assign to be equals. So whenever someone is assigning a variable, there will be an equal sign. There will be no equal sign if it's the entire equation. So I set that up as to be my parse. So right here, it starts to read the file, and if it contains the parse, if it contains the equal sign like this, it will assign the values accordingly. And I did that by splitting it and replacing all the spaces with no spaces and turning it into a string array. And I have it split by the parse. So that would leave us with just x and 5 in this case. So now in the first bit of the array there is x, and in the second bit of the array there is 1, or sorry, 5, and it would be at index 0 and 1 respectively. So now that I have it there, I call the variable table and I put in the values for the string, and I get the integer value for the string at the second bit. Otherwise, if it doesn't contain the parse, that means we're probably dealing with the actual proper equation. So in that case, it will go through the entire equation and make sure there's no just normal integer values like this 3 here. And if there is this 3 here, it does the exact same thing as the last time, but it now places the 3 as the string, and it'll have 3 as the integer value. And now it grabs the string here and it calls the string to expression. So now we jump to the string to expression. And we see here, I made these expression trees, these empty expression trees just to play with. And I made this variable tree here, or I made this string array here to basically to basically make it easy to access each bit in the string. So the very first thing I do is I print out the infix expression, which would just be this right here, just so the person running this file knows what they're doing, what is being calculated. And for the entirety of the file, so as it goes along the string array, it will check to see if each bit in the temporary string is a variable or an operand. So that calls the isOperand thing that I have set up here. So basically what this does is it grabs the string and the hash map, and it checks first to see if it is a operator. If it's an operator, it's just going to return false and throw no errors. However, if it is a value on the map, it'll return true. If not, it'll send an error. And if it is, and otherwise, it will grab it and check to see if it can be turned into an integer. And if it can be turned into an integer, it will return as true. And if it can't, again, it will throw an error and return false. So continuing on, it will grab whatever value is assigned there and make it into a new expression tree with that value. And then it will store the expression tree in the tree stack that I forgot to mention. Had a tree stack and an op stack here for the code for to store it, because we always need to grab the top bit of these values. We are not going to need to access the back of the stack. So the stack is the better option, at least in this situation. So if we end up figuring out that it isn't an operand and it is in fact a open bracket, it's just going to immediately push it into the stack, the op stack. And if the op stack is empty, it's going to immediately push in the operator into the op stack. Otherwise, if it is not empty and the operator equals the multiplication or the division, while the op stack isn't empty and the first bit in the operator stack doesn't equal plus, minus, or a closed bracket, because those would signify basically you'll need to stop whenever it reaches a plus, minus, or a closed bracket just to keep the order of things properly situated. So anyways, it will grab the first operator in the stack, pop that out, and it'll grab the first tree, pop it. They'll for sure here in this situation have at least one tree because of the condition up here. Otherwise, we're going to run into some errors that gets caught later. So if the tree stack is empty, it's going to print out an error and return the error tree, which is just null, and it will work rather nicely. So now that we're certain that we aren't having any errors, we merge the trees and store the tree. And I'll keep on doing this until it reaches one of these conditions up here. Similarly, it's the exact same thing with plus or minus. However, it will only stop if the op stack is empty or it reaches a open bracket. Also, something else I forgot to mention. This here is very crucial. This is when it stores the multiplication sign that it checked for, because we only have at this moment the left side of that tree. We don't have the right side of that tree, so we need to just temporarily put that off to the side until we get the other side of the tree. It has I have a very similar thing for the plus else if as well. So I have the exact same error here. If there's no trees in the stack, it throws an error and returns the error tree. Yes, I should also mention that if I don't make new expression trees right here, you can run into errors. The data allocation can be a bit wonky if you don't make a completely new expression tree. I ran into multiple errors because I initially had T1 instead of TA. So continuing on. So now this is when we run into the close bracket. So if we have the close bracket, it will get rid of the close bracket. It will discard it. And then if the op stack is empty, it'll throw an error saying that there's a missing bracket, because if we're throwing out the closed bracket, there should be an open bracket. Otherwise, it's just going to get rid of the other bracket. And if all those checks go through and it doesn't meet any of the requirements, it's going to throw an error, unrecognized operator, and return error. This is my pretty much catch-all error function, so it doesn't run into any significant errors that would crash the entire program. So now this is the final bit. This is when we have the entirety of the left side of the tree, we have the entirety of the right side of the tree, and no, sorry, we have the entirety left side of the tree, we have an operator, and then we have the root of the right side of the tree, and then that root's left and right tree. So we have to grab all those and combine them. So that's what I did here. I did a while loop. So basically it's going to pop out every single tree and combine them all together rather nicely. So this one right here, the very first time it goes through the loop, it will combine the right side of the tree. So there we have one operator, it will connect the left side and the right side. And then now we have hold on, I'm going to draw it. All right, so to make this all nice, so let's say we have multiplication here, and we have a tree here, and we have plus here, and we have a tree here, and we have a tree here. So these are the values we have right now. So the very first thing will happen is it'll pop, sorry, not that one. It'll pop this one, and this, and then it'll connect them. And now we have this, and we have this tree, and we have this tree here. And then the next time it goes through, it'll connect these, and we have a full functioning tree in the proper orientation for the expression. And now it will return the expression tree like normal. Now we have the full expression tree. So we come back to where we initially called it. That'll be right here. And then we go to this. Now we have the evaluation. So the first thing that happens is we jump over here and it goes to the evaluate. It carries over the hash map over because we need access to that to get the proper values to calculate it. And so it first checks to see if root is null. And if it's not null, it will grab the total and call root evaluate map. So it brings the map all the way over to here where I have the full evaluate method. So I just used a recursive definition of this. So if it's multiplication, I grab the left side and the right side and I multiply. If it's division, left side, right side, multiply. Same thing all the way through. And the important part is right here. So what I do here is I have x equals map get token. That should be simple. I grab the map that we carried over from the calculator and assign that value. And then we return the value and it goes all the way through the thing until we get the actual proper value, and that should return it properly. So now to show you that it works, we're going to run it. So there you go. Calculated value is 7. Let's try the next one. There you go. Calculated value is 4. And we can see that it is, in fact, correct. I think, hold on. All right, so this one here is also correct because 3 times 3 is 9, and divide that by 2, it rounds down to 4, just because that's how the code works there. And so let's test out the next one. This one is also true. You times any value by 0, you'll just get 0. So let's move to the next one. Value is 9. Let's see if this is correct. 0 times 0 plus 3 times 3. Yes, that is 9. And let's not run the same one again. Let's run a different one. I see. It returns 0 because this fraction here, 1 divided by 3, there is no uh, there's no remainder, so it returns 0. Sorry, there is a remainder. There's only a remainder. Here we come into the errors. So right here, it throws out the error values not on the hash map, and it gets more specific here, unrecognized operator. So that means this right here is not recognized in the code. So let's move to the next error. Too many operators. That one's obvious. This right here, that will mess it up. So let's go to the next one. Missing bracket, very simple. If you look, it's returning 0 every time there's an error, just so we don't have any issues. There you go. This is another one. So the value is not on the hash map. So again, these are not, or sorry, C right here would not be recognized. So that's the error that we're getting. And this is 10. I believe this is the last one. Yes. All right. Same issue here. Value isn't recognized. And let's make sure there's not any other errors that I'm missing. There you go. And that would be all of the errors that we can run through. So as you can see, the expression calculator does in fact work. Uh, Again, this is the second assignment, project 2 for Comp 251. And that's all.